Batteries hold the key to renewable energy's future. Nonetheless, the transition to renewable energy generation is a daunting task. We are all aware that for renewable sources like solar and wind to be valid, there's a need for energy storage to keep them running for extended periods. Lithium-ion batteries readily come to mind, but they are still prohibitively expensive for long-term storage. Pumped hydro storage is the world's most extensive battery system. Still, it is limited to areas with large bodies of water and vertical height differences. The rapid expansion of offshore wind power generation creates an exponential demand for large-scale energy storage. The oceans contain over 96% of the Earth's water. So what if we could turn the oceans or lakes into a battery? So, is there a slight chance this ocean battery can be a game changer for us all? Let's see if the future of energy storage lies in ocean batteries. Let's dive in without wasting any more time. Many companies and researchers are creating and testing underwater storage systems that convert the ocean and lakes into batteries to reduce storage costs. But how effective are they in practice? One of the options is known as buoyancy energy storage technology, and it was created by researchers at the IASA, International Institute for Applied Systems Analysis. Consider yourself on the beach or in the pool, and you force a ball underwater. Because the ball is filled with air, which is less dense than water, it must take a lot of force to keep it submerged, right? So while the ball is doused, it stores potential energy, which is the best principle. However, instead of a ball, BEST employs a platform anchored to the ocean floor and linked to a 100-meter by 100-meter array of high-density polyethylene pipes, each of which is filled with compressed gas, such as air or hydrogen. BEST works in tandem with floating solar power stations or offshore wind turbines. When a floating solar power plant or offshore wind turbine generates electricity, it powers electric motors that pull buoyant tubes down to the ocean floor to store potential energy. When energy is required for the grid, the tubes are opened. The upward force of the tubes drives the motor in reverse, acting as a generator and supplying electricity to the grid. After simulating the system and conducting an economic analysis, the researchers decided that the system could perform well in storing energy from offshore wind farms near coastlines and islands with no mountains. At the Best of Innovation Award CES 2022, Dutch startup OceanGrazer unveiled a new design for an energy storage system that works similarly to a hydroelectric dam at the sea's bottom. An ocean battery. What is an ocean battery and how does it work? The ocean battery is a scalable modular answer for a utility-scale energy repository powered by renewable energy sources like floating solar farms at sea and wind turbines. The battery is a pumped hydro system in a box that provides environmentally friendly utility-scale energy storage up to gigawatt-hours. The mechanism is founded on hydro dam technology, which has proven to be highly efficient and reliable for over a century. The system pumps water from rigid reservoirs into flexible bladders on the seafloor to store energy. The energy is now stored as potential energy in the form of high-pressure water. Water trails back from the flexible bladders to the rigid low-pressure reservoirs when there is a power demand. Multiple hydro turbines are driven to generate electricity. The buried concrete reservoir can hold up to 20 million liters of fresh water under low pressure. The system forces water out from the unbending reservoirs into the flexible bladder on the seafloor to store energy. The energy is now stored as potential energy in the form of high-pressure water. When there is an electricity demand, water flows back from the flexible bladders to the rigid low-pressure reservoirs, powering multiple hydro turbines. The concept behind this system is similar to that of onshore pumped storage hydropower. When the energy supply is more significant than the demand, you pump water to a higher altitude reservoir and then release the water to drive turbines downstream when demand is high. The power plant is already submerged in pumped storage water. On the seafloor, an enclosed vessel containing water is installed. When surplus energy is available, electricity pumps water out of the vessel to create a near vacuum inside. The water is then returned to the vessel utilizing the pressure generated by the seawater, flowing through a hydraulic turbine to generate clean electricity when the stored energy is required. The system has many advantages. It does not affect the existing landscape. Water quality does not deteriorate. There are no restrictions on water level and temperature. And the system generates energy by utilizing natural water pressure. Pressure rises by about 1 bar for every 10 meters of depth, and with the vessels at near vacuum, when the system is fully charged, there is a significant amount of energy to be captured. Some techniques are planned to operate at pressures greater than 75 bar, with efficiencies ranging from 69.9 to 79.9%, comparable to traditional pumped hydro storage. By adding more vessels and electricity-carrying cables, these underwater storage designs can be easily scaled up. Furthermore, unlike traditional pumped hydro storage, underwater systems do not necessitate the use of land in mountains or valleys to construct reservoirs. They also do not lose water due to evaporation, as open reservoirs do. The Stored Energy at Sea project was the first to put this concept into action in 2011. The Fraunhofer Institute for Energy Economics and Energy System Technology collaborated with Hochtief Solutions AG to develop a pilot project at the end of that year. It entailed constructing an underwater pumped storage system that used the sea as an upper storage reservoir and 30-meter diameter hollow spheres on the seabed at a depth of 700 meters as a lower storage reservoir. Following the experiments, the scientists discovered that their design was feasible at approximately 700 meters, where the pressure would be approximately 70 bar, using pressure-resistant materials. When fully charged, a single sphere could store 20 megawatt-hour of electricity, or 5 megawatts for 4 hours. Furthermore, a study conducted by the team revealed that an underwater energy storage design with close to 80 spheres could produce up to 400 megawatt, while costing between $0.04 and $0.21 per kilowatt-hour. MIT researchers worked on a similar project, using hollow 30-meter diameter concrete spheres with 3-meter thick walls that weighed thousands of tons. As a result, they could be used to anchor floating wind turbines. The sphere could store up to 6 mg of electricity at a depth of 400 meters. A single sphere, on the other hand, was expected to cost $12 million. As a result, the cost of storing energy in the sphere would be approximately $0.06 per kilowatt-hour. The ocean battery has an advantage over the technology developed in the Stored Energy at Sea project in that it is a sealed system. The battery requires little maintenance, and the materials used to construct it are steel, concrete, and rubber, or PVC, all of which are widely available. According to the company, a single reservoir with a capacity of 20 million liters could store up to 10 megawatt-hour of energy, and the system could be easily scaled up. The system's efficiency is expected to range between 0.7 to 0.8. Furthermore, the system is likely to run indefinitely and have a minimum lifetime of 240 months, though the developers stated that it could probably run for 360 to 600 months. No doubt, this ocean battery can be a game changer. So, what do you think? Do you agree with the level of research scientists are undertaking to give the renewable industry a game-changing solution? Do you think the ocean battery could become the answer to energy storage? Let us know your thoughts and opinions in the comment section. If this video is insightful, please go on and like this video. Remember to subscribe to our channel and click the notification bell for more updates.